Hi guys, today we're building something quite different, and to do so we're going to use Java, Android Java, and C. And to give a bit of context why we need so many things, as the title says, we're going to be adding Android audio support, or at least basis of it. And to give you a bit of context, let me just draw you an architecture diagram. So suppose we have a JavaFX developer and they are on this side, so that's JavaFX dev. And they'll be using some JavaFX libraries since Java 11. We've been using OpenJFX, which you all know. It has support for various things which are more or less platform independent. There are some things like graphics which are dependent on the platform, but they're implemented as several sort of layers of abstractions. So we have Windows, Mac, Linux, and so on. But if you want to use something that is platform specific, such as battery or accelerometer or something like audio that is being played on mobile, for example, then we would typically use something like Gluon Attach, which is a very nice project, and it provides developers with some serious hardware access and other things that are platform specific, especially on mobile. Now this thing is written in Java, and that's fine, but then we have a bunch of other layers in order to make it work. So this project was going to have some native calls. These native calls are implemented in Objective-C on iOS, and that will have to be implemented by somebody else because I don't speak Objective-C. And then we have Android Java. Android Java using Dalvik virtual machine. Now, because these two languages are Java, you might think, well, we just call methods directly. Unfortunately, it doesn't work that way because these are two separate environments. So we have to have a bridge of some sort. So in order to get to this, there is something in the middle called GNI, and that is written in C, which wires the methods from one Java layer to another Java layer. And that's kind of, these three things are what we're doing today. I doubt I'm going to finish this in one session, so I'll just do the basics and then we'll see how far this can go. I already thought about the general architecture of things, and it seems like the way to do this is to first call one of the load methods. So this is the attached Java layer, and on the right hand side I've got the Android Java layer, and somewhere in between is the C layer. So at super high level we have two methods only, which is great: load sound and load music. These are the things that will be part of the public API. So developers can call these methods and use the audio interface. Internally, what I'm thinking is we're going to first prepare the file. So we're going to copy the file from the APK, which, as far as I know, we still can't load directly. So we have to copy that into private storage of Android and then use it from there. So if this returns a valid full name to the file that is inside private storage, this is what this does. And if it fails, it returns an empty string. So if this returns an empty string, then we would need to fail somehow. How about we instead return optional audio? And that way we don't need to worry about exceptions or anything. Yeah, so this now becomes optional. This becomes optional too. If full name is empty, then return empty optional. If full name is not empty, then we've succeeded in preparing the file. And what we want to do is call the native load sound, pass the full name in there, which returns audio ID. And this is the ID or handle of our actual audio file, which is going to live inside the other Android environment. And passing primitives is relatively easier compared to passing objects. And then possibly initialize it with this. And this is going to be pretty much the same, except for this. In which case, oh yeah, that should be called in here. That's load music. Sound is a short-term sound effect. Music is something like an MP3 file, which is longer. So you don't want to load everything in memory immediately. You want to stream that. So in order to make any changes or control our audio, whether it's a sound or a music file, we're going to use this to pass these to the native layer. We don't need that, I don't think, because we can keep track of this internally. Is disposed false. And then when we call dispose, set it to true, call the native dispose, and then just return that. Okay. There might be another failure if this thing fails at the native layer. So we'll just return -1, I think. Yeah, I'm already kind of doing that. In which case, if this is -1, then again return this because we failed to load the audio properly. Okay, it's forming something. Right, this cache thing should be on this side. Somewhere here. So you can see the structure of it. In source main Java, we've got the Java code, and then in the native directory you have Android and Dalvik, Android C, Android Dalvik, and eventually there will be another directory called iOS, which will contain iOS stuff. But for now, let's see if we can make this work. Oh yeah, we use the ID to make a file. Okay, yeah, that looks good. Or at least better. And yes, we can pass in ints, we can pass in strings. On this side, with its own implementation, the signature has to match. So we'll load, create a pool, new file, yep, stream. Got the actual sound object. Then we want to cache it. Index, get free slot, and then cache index sound, and then return the index. And then do something similar for music. Also probably want to do something with exceptions. So we've got that. Yeah, so these things will have to change now. Is dispose is no longer needed. Good. Play, pause, stop, dispose, and then we need those two things. Get audio. Right, so this assumption is no longer needed because we're handling it as a cache. And this get audio takes the audio ID, which we can just return, I guess. Optional off. Nullable. And just in case we have to be, because this is super difficult to debug, we have to be incredibly careful with what we're doing. So let's just in case check that audio ID is within the range. So it's greater than 0. And greater or equal to 0. And it's less than the size of the cache. And we then return this. Otherwise return an empty one. Right, so when we dispose, we should also set cache to null, so that this specific place can be reclaimed and used by something else, by a new audio object. Okay, that looks fine. Sorry, I'm struggling with hay fever. Yeah, I think that looks fine. And we don't need URL. I can't see URL being used anywhere. Yeah, I'm pretty happy with this Android version. And I think we've got the Java version down too. Java is easier because I get ID support. Okay, let's go to the C layer. Now this is where things get tricky. First of all, we'll need to map all of these into JMethod ID things. I want to call them objects, but I don't think they are. They're probably structs or something. So this takes a string, returns an int, so it's no longer a void, it returns I, which is int. And then we've got 1, 2, 3, 4, 5, 6 methods to map. Set looping, set volume, play, pause, stop, and then dispose. So this is that. It is indeed a void. It takes an int. Okay, how do I say that it takes an int? Let's find a method. Call double void. Let's try that one. Okay, that one is interesting. Set detection. Set detection. So we need to find in BLE service this. Set detection. There we go. This is a private static void. Or what? It's not native. But can we still call it? Interesting. What if we use string? No, what if we use integers and then we try to map them somehow? Oh, there we go. We got start broadcast, which is native. So let's just find this one. Start broadcast. There we go. So it takes that thing, then I, which is integer, so that is correct, and then string in string. Good. So I can just say it's an int by saying one of these i's. Let's go back here. So I no longer need this, I don't think. Android audio service. Set looping. We take an integer and then a boolean. I know boolean is z, so that is probably what we do. It's a void, so we return v. Call volume. Let's go with that. Get method ID. This thing set volume, which is int and then double. Double I think is d, so it's id v because it's void. And then we do 4 more, but these are easier because play. Stop and then dispose. It's just play, and it takes an int, returns nothing. Dispose. Okay, that looks good. So we've got method IDs. It's like handles. Think of it as an object that is runnable, I guess. Actually, no. There's a thing in Java. Java reflect. Java lang reflect method. There we go. Yeah, think of these methods as this method. Then it just helps think about them. So this is from Java to Android. Okay, here we go. This thing returns an int. No, it returns JInt. Let's just see if there's any file that already does that. There we go. Android. Oh, it's iOS. Well, it doesn't matter. Yeah, that seems fine. So it does this, it takes a string, which is a JString, we do this conversion, call void method. Right, now how do I call an int method? Is it just call int method or call integer method? Unfortunately, there isn't a single method that calls an int. Just leave it as int, and then if it doesn't run, eventually we'll figure it out. Load sound, Android service load sound implementation. Yeah. That's the thing that gets passed in. Yeah. Oh yeah, we need to return something. So this is result, and we return result. There we go. I hope we can just use it directly without any conversions, because int there should be the same as this int. Let's see if there's a call double. I think there's call double. J double. Yeah, it seems to just use that. Yeah, so I assume that this is fine. In which case, that is also this, because that's load music and it's very similar. Call int and return result. I think that's the hardest part. The others seem a bit easier. Let's see. Well, first of all, they're all void, which is good. What they take is jint, which is audio ID, and they all call void method, so they don't return anything. What we need to figure out is what method they call, which is play, and we need to pass this thing as is, I would have thought, in which case we don't need this bit, and we don't need this bit, because we're not dealing with strings. Now this is readable. Well, you'll need to stretch the definition of readable a little bit, but it's better than all this stuff with string conversions. Let's play it. So let's do the 4 easy ones. That's going to be pause, then stop, and then dispose. Okay, I think that bit is done, which leaves us just these two to wire up, and then everything else is done, well, hopefully. Right, so for starters, these take two things. So it's J double, which is J looping, I guess. I guess J is added to kind of mark that it's Java and stuff that's being called. Get service set thing. Call void set looping audio ID, and then this thing is a wait. That's JBoolean. Nothing gets passed in here. I think that's done. And then the next one. We set volume. That's a J double. And that's J volume. Set volume method. Right, I think that's all the wiring up that we need. I can't actually test it right now, which is a bit annoying. I'll have to see how to compile all of this stuff and see if we can integrate this with the next version of Gluon Attach, which would be nice, because if you've seen the previous video on this channel, then you know that we have a stable build of FXGL on Android. And I would assume that it also will work on iOS. And the release will be following soon. So if we can match that release with Attach's next release, that would be really nice, because then we'd get audio support. So we can actually play sounds and music in our games, or in your JavaFX applications, whatever it is that you're developing. Right, on this note, I think I'm done. I have no idea. And I hope this was a little bit educational in terms of how the entire thing works. I'm still getting my head around all of this, but it's a lot of fun dealing with multiple paradigms, multiple languages, and seeing just how it all wires up and connects. In any case, I'll see you in the next video. Thanks for watching.